Sum and difference formula. The cosine of a difference of two angles, the sum, cosine of a plus b, is equal to cosine of a, cosine of b, minus sine of a times sine of b. And cosine of a minus b is equal to cosine of a, cosine of b, plus sine of a times sine of b. So for example 1, we want to rewrite cosine of 45. Well, because we don't have that on the unit circle, we can write cosine of 45 in terms of things that we have. Well, we know that we can rewrite this as cosine of 45 degrees plus 30 degrees. Because remember, 45 plus 30 is 75. So now we have that this is cosine of A plus B. So that is equal to, so we're going to use the cosine of A plus B formula here, which is cosine of A, which is our 45 degrees, times cosine of B, which is my 30 degrees, minus sine of 45 degrees times sine of 30 degrees. So we know cosine of 45 is square root of 2 over 2 times cosine of 30 degrees is square root of 3 over 2 minus sine of 45 is square root of 2 over 2. And sine of 30 is 1/2. So we have square root of 2 times square root of 3, which is square root of 6 over 4, minus square root of 2 times 1 is square root of 2 over 4. 2 times 2 is 4. And we can write this as one big solution. That could be all over 4. And we can just say that's square root of 6 minus square root of 2 all over 4. Example 2, we have cosine of 87 times cosine of 93 minus sine of 87 times sine of 93. Well, that, notice that follows along with cosine of A plus B formula. Here A is 87 and B is 93. So we can say that that's just going to be cosine of 87 degrees plus 93 degrees. That gives me cosine of 180 degrees, and we know cosine of 180 is -1. Example 3, we're going to verify the identity that cosine of pi minus x is equal to -x. So once again here, A is pi, B is x. So we're looking at cosine of A minus B, which is cosine of A times cosine of B plus sine of A times sine of B. And we just said that A is pi. So cosine of pi times cosine of B, B is x, plus sine of pi times sine of x. Well, we know cosine of pi is -1 times cosine of x, plus sine of pi is 0 times sine of x. So -1 times cosine of x is negative cosine of x, plus 0 times anything is 0, which gives me negative cosine of x plus 0 is negative cosine of x. And we just verified the identity. Example 4, we're going to verify cosine of alpha plus beta plus cosine of alpha minus beta is equal to 2 cosine of alpha cosine of beta. So I'm going to apply that my A is alpha and my B is beta. So we have cosine of A plus B. So we have cosine of alpha cosine of beta minus sine of alpha sine of beta. Then we have plus cosine of alpha minus beta. So then we have plus, our A is alpha and our B is beta. So we're using the cosine of A minus B formula. So we have cosine of alpha, cosine of beta, plus sine of alpha times sine of beta. And when we collect our like terms, notice we have cosine of alpha, cosine of beta. We have two of those right here and right here. So we have 2 cosine of alpha, cosine of beta. And notice negative sine of alpha times sine of b cancels out with plus sine of alpha, sine of b. So my final answer is 2 cosine of alpha, cosine of beta, and that's exactly what I was verifying. Find the exact value of sine of 105. So that's going to be sine of 60 degrees plus 45 degrees, and that will give me sine of 105. So we have that sine of A is 60 and B is 45. So I'm using the sine of A plus B formula. So we have sine of A, which is 60 degrees, cosine of B, which is 45 degrees, plus cosine of A, which is cosine of 60 degrees, times sine of B, which is 45 degrees. So we know sine of 60 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Plus cosine of 60 is 1/2. Times sine of 45 is square root of 2 over 2. So we have square root of 6 over 4 plus square root of 2 over 4. So we can write this all as square root of 6 plus square root of 2 all over 4. Example 6, sine of 40, cosine of 160 minus cosine of 40, sine of 160. That follows the sine of A minus B formula. So here this is sine of 40 minus 160 degrees. That gives me sine of negative 120 degrees. If you can't figure out what sine of 120 is, remember I told you guys you can always add 360 and make it a positive coterminal angle. So you can always say that's the same thing as sine of 240 degrees. Look on the unit circle what sine of 240 is. You're using the y value. So sine of 240 is negative square root of 3 over 2. Example 7, we're going to verify sine of x plus pi over 2 is equal to cosine of x. So here we have sine of a plus b. So our a is x and our b is pi over 2. So we have sine of x cosine of pi over 2 plus cosine of x sine of pi over 2. We have sine of x cosine of pi over 2 is 0 plus cosine of x. Sine of pi over 2 is 1. Sine of x times 0 is 0 plus cosine of x times 1 is cosine of x. 0 plus cosine of x is cosine of x, and I just verified the identity. Example 8, we're going to verify that sine of alpha minus beta all over cosine of alpha times cosine of beta is equal to tan of alpha minus tan of beta. So I'm going to start with the numerator, which is sine of alpha minus beta. So we have that A is alpha, B is beta. So we're using sine of A minus B formula. So we have sine of alpha cosine of beta minus cosine of alpha sine of beta. And this is all over cosine of alpha, cosine of beta. And I'm going to split my denominator. So now we have sine of alpha cosine of beta divided by cosine of alpha cosine of beta minus cosine of alpha times sine of beta over cosine of alpha cosine of beta. So So now I'm going to simplify. The reason why I need to do that is because my final answer needs to be tan of alpha minus tan of beta. So the only way this would happen is if I split the fraction. Notice the cosine of beta cancels out in the first one. So now I have sine of alpha divided by cosine of beta, which is tan of alpha, minus, notice that the cosine of alpha minus cosine of alpha cancels out, and sine of beta divided by cosine of beta is tangent of beta. So here I just verified the identity. Sum and difference identities for tangent. Tan of a plus b is tan of a plus tan of b divided by 1 minus tan of a, tan of b, and tan of a minus b is equal to tan of a minus tan of b divided by 1 plus tan of a times tan of b. So find the exact value of tan of pi over 6 plus pi over 4. So that's tan of a plus b, which is tan of a, which is pi over 6, plus tan of b, which is tan of pi over 4, divided by 1 minus tan of pi over 6 times tan of pi over 4. And we know tan of pi over 6, well, sine of pi over 6 is 1/2, and cosine of pi over 6 is square root of 3 over 2. So therefore, tan of pi over 6 is 1 over square root of 3. So it would be square root of 3 over 3 if you rationalize it. Plus tan of pi over 4 is 1 divided by 1 minus tan of pi over 6 is square root of 3 over 3. Tan of pi over 4 is times 1. So here I'm going to get a common denominator, which is going to be square root of 3 over 3 plus 3 over 3. So that's going to give me square root of 3 plus 3 divided by 3 on the numerator. And on the denominator, we have 1 minus square root of 3 times 1 is square root of 3 divided by 3. Once again, getting a denominator of 3 over 3, that will give me 3 minus square root of 3 all over 3. Notice the 3's will cancel out. So my final answer here will be square root of 3 plus 3 divided by 3 minus square root of 3. Example 10, we're going to write each expression and then we're going to find the exact value. So in this case, it's tan of 100 degrees minus tan of 70 divided by 1 plus tan of 100 times tan of 70. That follows tan of a minus b formula. So a is 100, b is 70. So that's tan of 30 degrees. We know that sine of 30 is 1/2. We know cosine of 30 is square root of 3 over 2. The 2's cancel, leaving me with 1 over square root of 3. So if I rationalize this, that's square root of 3 over 3. Example 11, we're going to verify that tan of 2 pi minus x is equal to negative tan of x. So we have tan of a minus b. So tan of a, which is 2 pi, minus tan of b, which is x, all over 1 plus tan of 2 pi times tan of x. So tan of 2 pi, notice that that's going to be y over x. So it's going to be 0 over 1, which is 0, minus tan of x on the numerator. And on the denominator, we have 1 plus tan of 2 pi, which is 0 times tan of x. So on the numerator, we have 0 minus tan of x, which is negative tan of x. And on the denominator, we have 1 plus 0 times tan of x, which is 0. So we just have 1 plus 0. So we have negative tan of x over 1, which is just negative tan of x. So I just verified the right-hand side. Example 12, we're going to verify that tan of theta plus pi over 4 is equal to cosine of theta plus sine of theta, or divided by cosine of theta minus sine of theta. So we're going to use tan of a plus b formula here. The identity will be tan of A plus B, so it'll be tan of A, which is theta, plus tan of pi over 4, which is our B, 1 minus tan of theta times tan of pi over 4. So we have tan of theta plus tan of pi over 4 is 1, divided by 1 minus tan of theta times tan of pi over 4, which is 1. So we have tan of theta plus 1 divided by 1 minus tan of theta. So I'm going to rewrite tan of theta plus 1 in terms of cosine. So that will give me cosine and sine. So that will be sine of theta over cosine of theta plus 1 divided by 1 minus sine of theta divided by cosine of theta. We're going to get a common denominator. So sine of theta divided by cosine of theta plus cosine of theta divided by cosine of theta on the numerator. And on the denominator, we're going to get a common denominator of cosine. So that's going to be cosine of theta divided by cosine of theta minus sine of theta divided by cosine of theta. So now we have, on the numerator, we have sine of theta plus cosine of theta divided by cosine of theta divided by cosine of theta minus sine of theta all over cosine of theta. Notice that the cosines of thetas will cancel out, leaving me with sine of theta plus cosine of theta divided by cosine of theta minus sine of theta. And that's exactly what we were verifying. Find the exact value for the following under the given condition. We have sine of alpha is 3/5 and alpha lies in quadrant 1. So I'm going to sketch alpha. Alpha is in quadrant 1. My y is 3. My r is 5. I can find x by saying x squared plus y squared equals r squared. So we have x squared plus 3 squared, which is 9, and r squared, which is 25. So x squared plus 9 equals 25. Subtracting 9, we get x squared equals 16. And when I take the square root, it's always plus or minus. But we're in quadrant 1, so x is 4. And so for that, right, this particular one, I have that cosine of alpha is 4 over 5. And then I'm just going to write down tangent of alpha as well. So tangent of alpha will be y over x. So that way I can use the information. For the second one, we have that sine of beta is 5 over 13, and beta is in quadrant 2. And that we have here that x is unknown. We know y is 5. And we know r is 13. What we also know that is that x has to be negative. So once again, we have x squared plus y squared equals r squared. X squared plus 5 squared equals 13 squared. I'm going to go ahead and subtract that. 13 squared is 169 minus 5 squared is 25. So we have x squared equals 144, and when I take the square root of both sides, it's always plus or minus. So in this case, since we're in quadrant 2, it's negative 12. So for that one, we have that cosine of beta is negative 12 over 13, and tan of beta is equal to 5 over negative 12. So now I have all the information I need to apply the formula. The first one is cosine of alpha plus beta. So that's cosine of alpha, cosine of beta minus sine of alpha, sine of beta. So that will give me cosine of alpha was 4/5. Cosine of beta is negative 12 over 13. Minus sine of alpha was given, which was 3/5. And sine of beta was given, which is 5 over 13. 4 times negative 12 is negative 48 over 65. 5 times 13 is 65. Minus 3 times 5 is 15. 5 times 13 is 65. We already have the common denominator. Negative 48 minus 15 is negative 63 divided by 65. Next, we have sine of alpha plus beta. So that's going to give me sine of alpha cosine of beta plus cosine of alpha sine of beta. Sine of alpha was 3/5. Cosine of beta was negative 12 over 13. Plus cosine of alpha was 4/5. Sine of beta was 5 over 13. 3 times negative 12 is negative 36 over 65. 5 times 13 is 65. 4 times 5 is 20. 5 times 13 is 65. And negative 36 plus 20 is negative 16 over 65. And tangent of alpha plus beta is going to be tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha tangent of beta. So here we have tangent of alpha was 3/4 plus tangent of beta was 5 over negative 12 divided by 1 minus tangent of alpha was 3/4 times tangent of beta is 5 over negative 12. Okay, I would use a calculator and I would hit 3/4 plus 5 divided by negative 12, or you can get a common denominator, and I get 1/3 on the numerator, divided by 1 minus, put a parentheses, 3 divided by 4, another parentheses, 5 divided by negative 12, close the parentheses, hit math fraction, and I get 21 over 16. And now I can put that in the calculator, hit 1/3 divided by 21 over 16. So parentheses 1/3 divided by parentheses 21 over 16. And then hit the math fraction button and you get 16 over 63. So 16 divided by 63. Example 14, find the exact value. So cosine of alpha is 8 over 17. Alpha lies in quadrant 4. Sine of beta is negative 1/2. Beta lies in quadrant 3. So alpha is in quadrant 4. And we have that x is 8, r is 17. We have x squared plus y squared equals r squared. 8 squared plus y squared equals 17 squared. So 64 plus y squared equals 289. Subtracting 64, 289 minus 64 is 225. And when I take the square root of both sides, The square root of 225 is 15, so y equals plus or minus 15, but we're in quadrant 4, so y is negative 15. So I'm going to go ahead and write down all my information. I already have cosine of alpha is 8 over 17, so we know sine of alpha is going to be negative 15 divided by 17, and then tangent of alpha is going to be negative 15 over 8. For beta, we're in quadrant 3. Here we have that y is negative 1, r is 2, and we don't know what x is, so we're going to find x by saying x squared plus y squared equals r squared. X squared plus negative 1 squared equals 2 squared. X squared plus 1 equals 4. Subtracting 1, x squared equals 3. And when I take the square root of both sides, it's plus or minus square root of 3. But in this case, because we're in quadrant 3, it's negative square root of 3. So we have cosine of beta is negative square root of 3 over 2. And then tangent of beta is going to be y, which is negative 1 over x, which is negative square root of 3. And if I rationalize that, that's going to be square root of 3 over square root of 3. And it's positive because we're in quadrant 3. Negative divided by negative is a positive. So the first one we have is cosine of alpha plus beta, which is cosine of alpha, cosine of beta minus sine of alpha, sine of beta. Cosine of alpha is equal to 8 over 17. Cosine of beta is negative square root of 3 over 2. Minus sine of alpha is negative 15 over 17. And sine of beta is negative 1/2. So we have negative 8 square root of 3 over 34 minus negative 15 times negative 1 is 15, but keep in mind that that was a minus sign, and 15, and then 17 times 2 is 34. So this is going to be negative 8 square root of 3 minus 15 all over 34. B is sine of alpha plus beta, which is sine of alpha cosine of beta plus cosine of alpha sine of beta. So sine of alpha is negative 15 over 17 times cosine of beta, which is negative square root of 3 over 2, plus cosine of alpha, which is 8 over 17, and sine of beta is negative 1/2. So we have negative times a negative is a positive 15 square root of 3 divided by 34 minus 8 times negative 1 is going to give me that negative sign, which is 8 over 17 times 2 is 34. So I can rewrite this as 15 square root of 3 minus 8 divided by 34. And the last one, tan of alpha. Tan of alpha plus beta will be tan of alpha plus tan of beta divided by 1 minus tan of alpha tan of beta. So tan of alpha is negative 15 divided by 8 plus tan of beta is square root of 3 over 3 divided by 1 minus tan of alpha, which is negative 15 over 8, times tan of beta, which is square root of 3 over 3. On the numerator, you can get a common denominator of 24. So if I multiply by 3 and multiply this side by 8, I have negative 45 plus 8 square root of 3 all over 24 divided by, and on the denominator we have basically 1 plus 15 square root of 3 divided by 24. If I get a common denominator of 24, that will be 24 plus 15 square root of 3 all over 24. And notice the 24s cancels out, so my final answer here will be negative 45 plus 8 square root of 3 divided by 24 plus 15 square root of 3.